So yes, thank you very much for inviting me to have a talk in this very nice forum. It was hard time for me to follow the two first presentations, but fortunately there was a translation and these were very interesting ones. In my presentation I'm dealing something which has happening during a very long time in many Western countries, that achievement in mathematics has not improved or it has decreased, and particularly when we compare it with the Asian countries, many politicians and even researchers have been worrying about the level of mathematical achievement in Western Europe, and the same also in USA. And one issue which is related to that is then the differentiation, so that some still, even though general achievement is going down, some students are doing very well, but those who do not do well do worse than earlier, so that then the differences will increase. And these are challenges which many countries are nowadays dealing with. And why this is so important? It is because proficiency in mathematics is not only important for individuals, but it is also very important for the society as whole. And because of that, it's not only a kind of individual issue, but it's also very much a political issue. What political decision makers they are worrying about. So according to very many longitudinal studies, some of them have been studying same individuals 20 years even, have shown that a very low mathematical achievement is a kind of risk factor for many individual things. Of course, there's a lot of evidence showing that low mathematical achievement predicts unemployment, longitudinal unemployment. It also typically predicts very low salary works if people can get work. It also predicts all kinds of social difficulties and even health problems. Of course, it's related to the living styles and so on. And there are also studies which show that very low mathematical skills predict even criminality. So that from individual point of view, it's very important that we can find solutions to help students in learning mathematics. From society point of view, of course, mathematics has always been valued, and it has been a part of, particularly in industrialized countries, it has been important. There are many professions which require a lot of mathematical skills. But also, if you think the kind of everyday life of people in today's society and in future, the lack of mathematical skills is a very serious problem. And so the societal activities and also, and particularly what is happening in the working life require more mathematical thinking, and what is more challenging, new type of mathematical thinking, which means the ability to apply mathematical thinking in a very flexible way in situations which are not explicitly mathematical, so that people have to be able to see the opportunity to apply mathematical thinking in new kind of situations. Okay, this is the background, and when I was asked to present here, I wanted to look at what is happening in Lithuania, even though I don't use the Lithuanian data in my presentation, but I have the same big figures as which was already presented here. And of course, based on these figures, Lithuania don't have any big problems. So in both groups, there's an increase in international comparisons. There's also, for example, these values are on relatively high international standards. And if we look then these distributions, we can see that the low achieving group is going smaller and the high achieving group is increasing, and this is not very long, this distribution, so that the differences are not particularly high, but of course there are differences, and these are important to take into account. But that's about Lithuania. Then I tried to deal with these issues more based first on Finnish data, this kind of evaluation studies in Finland, then based on international research literature and also our own studies, what we have been doing in the field of mathematics. And then I start by looking what has been the impact of the lockdown of schools during the COVID epidemic on achievement. I think that when we look, for example, what is going in matriculation exams or other large-scale evaluation or assessment studies, and if this has been done now during last year, we have to take into account that there was very special period for students, and this must have effect. And now I try to demonstrate it with a very brand new Finnish data, what could be the effects of this lockdown. And this is now data from the from the Finnish Education Evaluation Center. I think it's very similar organization you have here, and the difference is with the Finnish and Lithuanian system and Finnish and many other systems is that this evaluation center doesn't do any high-stake testing. Everything is based on samples, and the aim is to support the qualitative development of education system. It's not a control mechanism, and this is very kind of conscious political decision that has been made already a couple of decades ago, that the national evaluation is not high-stake evaluation, but this kind of development-oriented evaluation. Okay, but now this is the most impressive figure we have now. These are the last 3 big evaluations of mathematics. The first, the red one is 2012, blue one is 2015, and the black one is 2021. And of course, the black one was then after lockdown. And in general, from these figures, you can see that there was a small increase in the average achievement from, because of course these are not exactly the same test, but they are very carefully made plans so that we can directly compare the numbers. So this is a very small improvement from 12 to 15, and then relatively strong decrease in achievement in this 2021 measurement. But what is much more interesting is to look that these 2 lines, the red and blue, these are so-called normal curves, but the black one is not anymore a normal curve. And when we kind of look them mathematically, there's a very interesting phenomena, so that instead of one normal curve, this describes in fact 3 separate populations. We can model this data with 3 different populations, and that is something completely new. Never in these large evaluation studies we have had that, but always there have of course been good achievers and high achievers and low achievers, but always the data has been more or less normally distributed. But this data is not, cannot be described in one normal distribution, but with these three distributions. And when this was connected to all kinds of background information, there were very clear explanations for those extreme lines. So there were victims and winners of lockdown. Those who belong to this red population, they typically have special needs, had a special needs status already before pandemic. They had low prior achievement when we look at the school grades. They had relatively low self-regulation skills, low socioeconomic family background, quite typically also immigrant background, and parents had low education. Whereas these winners, they had high educational and academic ambitions, high self-regulation skills, high socioeconomic background, high parent education, and quite many of them were also studying in specialized schools, schools which were specialized in STEM education, science, technology, engineering, mathematics education, or specialized classrooms. If in a bigger school, some classrooms are specialized in these areas, so that all these characterized these groups. And now it is very interesting to see what happens when students have returned to the school, back to the schools. If this kind of tree population model continues, or if the same students after increasing education are coming back to one distribution. And this is also from scientific point of view, quite interesting question. Of course, it has big societal importance because it's very dangerous that we have that kind of phenomenon. But what happens? Something similar we know from many other countries when they have been looking the impact of lockdown, and it also tells that there is a group of students who in fact benefited about the lockdown, so that this kind of opportunity for them to study with their own, of course they typically had parents who were able to help them, but they were able to go maybe faster to look in different ways, mathematics and so on, and they developed skills which were in fact higher than so that there's a very small group here which had higher achievement than the good students had in earlier measurements. And that's all is quite interesting, but when we think about the effects of the lockdown. But all this explains that there are many background variables which seems to explain mathematical achievement, and it was also presented in here already in these two earlier presentations. And if we look it with the Finnish data a little bit more, and this is we are happy to have a very longitudinal comparison starting from 1950s and come until 2020, and these are describing how much the socio-economic background is explaining school achievement. And there have been all kinds of earlier studies which made it possible to compare the socio-economic background and school achievement. And then nowadays there are the data sets from international comparison studies. But there is interesting development happening, so that it started so that the socio-economic background was very strong predictor of school achievement. And at that time, Finland has a traditional educational model with a tracking system, so that after 4 years common school education, then so high achievers went to different schools than more low achievers. Of course, it was not only based on the achievement level, but also parents' hopes and students' motivations and many things. But this was very strongly related to socioeconomic background, so that high students from higher socioeconomic families went to this kind of upper level, this academic track, and others then to the non-academic track. But then in 1970s we created this comprehensive school model, and there was these two school systems were put together, and the very clear aim was to improve quality of education, but on the same time equality of education. To combine these two things, which normally are considered to be different, which cannot be combined. And we can call that there was something we can call the kind of golden years of Finnish comprehensive school, when it worked very well. So there were good resources for support for low achievers, and there was also very kind of strong unified culture which was supporting education. And so that even in families with very low socioeconomic background, with almost no, very low educational background, they supported very much their children's education, and this was highly valued in all societal groups. And that was the period where we reached the situation that socioeconomic background was not very much predicted. It was not a zero prediction, but it was not very much predicting school achievement and then the further education who went to the university. But something strange happened. It didn't last. And what explains that? One thing was that in the beginning of 1990s we had extremely deep economic regression, and it has had many consequences. Very concrete consequence was that schools after this period have had much less resources to support low achievers than we had before. And even more important thing is that because of this deep economic regression, there was very large unemployment, and in certain areas of the country and in some areas in bigger cities, there is a new phenomenon which is a kind of heritage unemployment, so that the father was already the grandfather was already unemployed, the father was unemployed, and it's particularly harmful for boys' motivation to study, because they do not have any future perspectives. But why to study? Why to put effort in learning? And then there was also increase of immigration, which happened on that time, and then in more this kind of increase of individualistic values, and also in many systems some kind of new liberalist solutions. For example, the the school choice, so that earlier every child went to the closest school, but then the kind of school shopping became much more popular and all these increase the importance of socioeconomic background for students achievement. But this big figure explains that it is possible to have a situation when the socioeconomic background does not play very strong role, but it means that there is some features in the society and also very strong support in schools for those who comes from lower socioeconomic backgrounds, who have more learning disabilities, do not have the skills, the self-regulation skills, the metacognitive skills and so on, what typically develops in families of educated parents. Okay. Another thing was the immigrant background, and that was from this latest study of mathematics. And the red one is the immigrant background students, and you can see that it is a very, very strong difference when we compare. And that is interesting that in some other countries, let's say for example in Canada, where they have a lot of population which are not originally Canadian but have came there. For example, in the early PISA studies, there was a discussion that should we take the immigrant populations away from the data, because in many countries it lowers the average value, but in Canadian was against that, because in their case it higher the average achievement of students. So there are many things. One was, of course, that they are selecting systematically the immigrants who can come to the country, so that they typically are very, very active, motivated, already highly educated people coming. And maybe also the culture, it's much better to cope with cultural diversity. Finnish culture, and I think it's the same here in Lithuania, you have very kind of unified cultural traditions, and it is not so easy for schools to cope with very rapidly increasing cultural diversity, and that's something which we can clearly see in Finnish schools. But also the quality of teaching matters, and when we think the quality of teaching or quality of teachers, then there are at least two things. And when we think about mathematics, there is a lot of evidence that mathematics teachers have to know mathematics, what makes sense, so that they have to have strong subject knowledge and no proficiency in this context and these topics they are teaching. And we have very interesting demonstration of that in this last large-scale evaluation, because there's a new component in our mathematics curriculum, which is computational thinking and algorithms. This wasn't in the curriculum earlier, but now it was. And only in some schools the teachers have had the training. Of course, it's depending on their own activity, but in some schools they have been very active to get that training. In some other schools they didn't have that training. And there's a huge difference in students' achievement depending on that how well teachers were prepared to teach that new topic in mathematics curriculum. So, okay, from this we can believe that yes, content knowledge matters, that if teachers really know the content very well, because traditional mathematics teachers do not necessarily know what computational thinking is, or at least not so well than those who really have made courses about that and studied about that. Okay, but what is the other term which is used when we describe teachers' competencies in the field of mathematics education particularly, but of course in other fields as well, is teachers' pedagogical content knowledge. And pedagogical content knowledge in mathematics refers to teachers' knowledge about typical misconceptions students have, which are challenging concepts to learn, and what kind of methods are suitable to teach particular mathematical topics. So that it's not kind of general pedagogical knowledge or skills, but very content-specific pedagogical skill. And this teacher's pedagogical content knowledge is related to their ability to notice what students are thinking, what they, when they do have problems, if they have misconceptions or something which then is misleading their future learning, and also gives them and how they have to give right support at the right time, which is very important in mathematics learning. And there are a lot of literature, international literature, showing that the mathematics teacher's pedagogical content knowledge is even more important predictor of students' learning achievement than the content knowledge. And of course, that it means that there's that there's a need to support teachers' continuous professional development in these issues. Okay, so a few concluding remarks, how to deal with individual differences and kind of overall quality of mathematics learning. So how to avoid too large differences in students' mathematical achievement? There will always be differences. That's of course the starting point. But if the differences are too large, then it's becoming it will be a societal problem. Of course, it's an individual problem, as we started in the beginning. But it also, when we look the comparisons internationally, then two big differences also lower the average typically. So students with low mathematical achievement need specific help already during the primary level. So there's a lot of empirical evidence showing that the first 2-3 primary school years are relatively easy. So that is very basic arithmetic with natural numbers. All students more or less learn what we are teaching there. But then, during the 3rd, 4th, 5th grade, the differences start to increase. And that is exactly the point when it is extremely important to have a very strong support for those who don't get the idea about mathematical thinking. Because what we know from the research is that then there are 6th graders, 7th graders, 9th graders who are sitting in the mathematical classroom but have no idea what is going on. So that they have completely lost the kind of intellectual control for these topics. They can repeat mechanically something which is taught, but not develop the mathematical thinking. And it is surprising when we look some studies that students do not improve at all the mathematical thinking from 4th grade to 9th grade, for example. So that they stay on the same level all the time, which is of course very sad if you think it from the individual point of view, and very serious if you think it from a societal point of view. So it's extremely important to find methods how we can help them to think mathematically. So, there are good examples. There are schools where people have managed to do, teachers have managed to do that, but then many schools where they do not manage to do that. And it is so that when we look at as an education system, it is clear that schools which are located in areas where a big part of the families have very low socioeconomic background, where they have a lot of immigrant students, it is important that we keep more resources there, because they absolutely need more resources, because the tasks they are dealing with, the challenges they are dealing with are much bigger. We call it positive discrimination. For example, in Finland we have very well-developed model in the city of Helsinki, so that because the Helsinki area has very different areas where the schools are located, they carefully look the challenges of the family background and then give resources accordingly. And as I mentioned, that one reason for problems, particularly of boys, is that they do not see the meaning in this formal mathematical thinking. Why to study? Why to work? Push effort on that. So it's very important to teach mathematics also in that way, which immediately make it clear how can I apply that kind of thinking in everyday life. Of course, mathematics is a topic which is quite abstract, and it has this value as its own, as this abstract, but it's on the same time something what people need in their practical life, and schools very often completely fail in making sense of mathematics outside mathematics classrooms, and this is a big challenge, and we have already some early evidence that it really helps those boys who are not otherwise motivated in mathematics. And then how to improve overall quality of learning mathematics. There's one point which has been emphasized recently, because there's a lot of research evidence of that there are particularly mathematical concepts and processes which have a kind of generic nature, so that they have long-lasting effects. So that when we deal with these issues, we are not only teaching this topic and then we move to some other topics, but these certain topics is extremely have an extremely strong impact on later learning. And if we start from very early on, in basic arithmetics, of course, this fluency, that it's fluent enough to remember enough simple arithmetic facts, has been shown to be important for future learning of mathematics. But what is even more important is that when primary school students learn basic mathematics, they do not learn them in a linear way. That, for example, 2 plus 3 equals 5 is one sentence they remember, and then 3 plus 2 equals 5 is the other one which is not related to the first one. But they should understand already this basic arithmetic properties in a systemic way, that A plus B equals C is also B plus A equals C, is C minus B equals A, so that they create this kind of numeric networks, numbers and operations already when they first time learn. This really have a strong influence on their later learning. Then there is now very large evidence from international longitudinal studies that the rational number concept, very high level understanding of rational, the level of understanding of rational number concept is the strongest predictor of later mathematical learning, even very advanced mathematical learning on upper secondary level. So that when we looked the longitudinal data, how well students learn to understand fractions and decimals and percentages and this whole system of rational numbers is the strongest predictor of, let's say, upper secondary school mathematics achievement. This kind of thinking, when moving from natural numbers to rational number thinking, is a kind of prototype of moving to mathematical way of thinking, and that's probably one of the gains. Also, similar one. These are only examples. This is not a complete list. Also, the deep understanding of equivalence is a similar generic thing. It helps, even if it already when students learn simple arithmetic, can think about equal sign and equivalence in a flexible way. It's much easier for them to learn equations later on when they are studying upper mathematics. And that's the same in symbols in algebraic sentences. There are many misconceptions students have in that. And if we can avoid from the beginning the misconceptions, it helps then later studies. So this is one important thing. Then there will be a presentation later today about flexible strategies in mathematics. We have also made a lot of research on that field, and it seems that it is extremely important for future mathematical learning that students are encouraged to explore with mathematical procedures and to develop flexible strategies. Immediately when they knew something, they studied something new, that they also try to study that not only as mechanical algorithms, but as a kind of flexible thinking. And practice is extremely important in mathematics learning. However, there has been a lot of criticism about this traditional way of practice, which seems to develop this kind of mechanical knowledge, this kind of drill and practice type things. So it's very important to create something which is so-called deliberate practice. We know it from the expertise research, a certain type of practice, which means intensive and varying practice, which does not only automatize the procedures, but also push at the same time this conceptual understanding and flexibility further. So it's very intensive practice, but different type of practice than the mechanical practice we typically know in schools. And it's also important because often, I don't know if it's a problem here, but in many countries that some teachers have misinterpreted learning research outcomes, that self-regulation would be a teaching strategy. No, it is not. Self-regulation is an aim of teaching, and it needs a lot of support, a lot of very systematic support from teachers to develop this kind of self-regulated knowledge or self-regulated skills to deal with mathematical knowledge. And that's why the role of teachers support and high quality support is very important. Okay, thank you for your attention.